Hello everyone, welcome to the Unacademy platform. Let's crack it. In the today's video, so what we are going to discuss in the today's video? In the today's video, we are going to discuss about the complex variables part 3. It's very important part. Analytical functions. That's the Riemann equations. Today we are going to discuss in the complex variables part 3 video. Coming to the Unacademy Compact. So Unacademy is the weekly largest competition for GATE and ESE in the Unacademy platform, and access your GATE preparation within the 60 minutes. Challenging and original GATE questions curated by the best educators in the platform. Take it live to compete with the best, super fast and fun with the All India live leaderboard. Identify and improve your weak areas through the detailed video solution. And use the referral code Moorthy536 invite code to attend the Unacademy Compact. And day after tomorrow, coming Sunday, 18th July, third compact in the July month. Test starts at 11 AM, and you can get the benefits. What are the benefits you can get? And if you crack the GATE and ESE, then you can avail. Then you can avail. If you secure the rank from 1 to 3, the complimentary Unacademy Plus subscription for 1 year. And if you secure the rank from 4 to 10, 75% offer on the Unacademy Plus subscription for your teacher of your choice. Rank 11 to 50, 50% offer on the Unacademy Plus subscription for the teacher of your choice. So these are all the benefits you are getting. 51 to 100, 25% offer on the Unacademy Plus subscription. Winners can choose from 6 months, 12 months, 18 months and 24 months GATE and ESE subscription. The terms and conditions are applied for this part. And Laksha Access Arohan. The Laksha for GATE and ESE 2022, it's batch E. Arohan for GATE 2020, GATE and ESE 2023. Praveen Kulkarni sir, Devendra Singh Negi sir, JS Gill sir, Rajiv Singh, Agatya sir and Aditya Gupta. These 6 together handle the complete course for GATE and ESE 2022 and GATE and ESE 2023 in it's bilingual, Hindi and English, right? We start with metal cutting by Rajiv Singh, 6:15 PM. Already we have started course at July 14, right? 2021. Use the code Moorthy536 to join into the batch. And Spark and Wave, there are 2 more things available, right? Spark for GATE 2022 and Wave for GATE 2023. Mechanical English batches, batch B. Praveen Kulkarni, Devendra Singh Negi, Vivekanandan sir and myself. We 4 together handling the complete course for mechanical engineering completely in English. The course already started June 16, 2021, right? Use the code Moorthy536. So this is the code you need to apply to join into the batch. This is the right time to take the subscription in the platform and start preparing in the Unacademy platform. So Unacademy platform is one of the best platform for the GATE and ESE preparation. So you can easily crack the yes, it's tougher question also. We preparing the Unacademy platform. And now coming to the complex variables. And now we are moving to the complex variables, calculus chapter. Oh sorry, it's complex variable different, not the calculus, right? Sorry, it's not the calculus, it's complex variable completely. Now the analytical function. So what is analytical function? The yesterday itself we have completed the analytical functions. And what is analytical function? Everything in the previous. So this is the formula for the necessary and sufficient condition for f of z to be analytic. 2 conditions must be satisfied. In order to satisfy the given condition is analytical one. So what are the 2 given conditions? First one, it's dou u divided by dou x and dou u divided by dou y and dou v divided by dou x and dou v divided by dou y are continuous functions of x and y in the domain D. Now dou u divided by dou x and dou v divided by dou x, it's equal, both are equal, and dou u divided by dou y is equal to minus dou v divided by dou x. Okay, that is ux is equal to vy and uy is equal to minus vx. Uy is equal to minus vx. So the second condition is called as Cauchy-Riemann equation or CR equations. It's Cartesian coordinates. In order to satisfy the CR equation, That means analytical function, the function must satisfy the CR equations, right? It's a Cartesian coordinate. Now we are going to discuss the polar form equation. It's a Cartesian coordinate. It's a Cartesian coordinate. And coming to the polar coordinate, the same Cauchy-Riemann equation for the polar form. So how we are correlating the polar and Cartesian? By using the exponential parts, right? Already in the first video itself we have discussed. The transformation of Cartesian to polar coordinates, x is equal to r cos theta, y is equal to r sin theta. So we are taking the x is equal to r cos theta and y is equal to r sin theta. And z is equal to x plus iy. It's complex number. And r, so now we are going to take the value. We can write the same thing in terms of the Cartesian coordinates, right? Polar coordinates, trigonometric form. Now x is equal to r into cos theta, then y is equal to r into sin theta. If you substitute instead of x and y into the equation, and now keep the r as common term, into cos theta plus I sin theta, it's equal to r into e power I theta. F of z is equal to u plus iv. F of z is equal to u plus iv. It's equal to f of r into e power I theta. Now it's a CR equation in the form of polar. Dou u divided by dou r. It's equal to 1 divided by r into dou v divided by dou theta. So this is a formula you need to remember while solving the problems. Second formula. Dou u divided by dou theta, it's equal to minus r into dou v divided by dou r. Minus r into dou v divided by dou r. The above equation is called the CR equation in the form of polar. Now I will give you the one example problem for the Cartesian coordinates, and followed by the previous year questions now we are going to discuss. Verify its w is equal to x y plus I into x square minus y square plus 2xy is an analytical function. It's an analytical function. Now the w is equal to u plus iv. U plus iv is equal to such a value. Now the u, real part is called as u, the imaginary part is equal to v. It's x square minus y square minus 2xy is equal to u. Now v, it's I coefficients v, x square minus y square plus 2xy is v. Now ux, uy, vx, vy we need to calculate. Now calculate ux, it's equal to the function, it will be differentiated with respect to x. It's 2x, y 0 minus 2xy differentiation with respect to x, it's 2y. Therefore 2x minus 2y. And uy with respect to y, x 0 and minus 2y minus 2x. Now take the minus outside, 2x plus 2y. Now the function v, the imaginary part is differentiated with respect to x and followed by with respect to y. Vx is equal to 2x plus 2y. Vy is equal to, now it's minus 2y plus 2x. Now the condition, what will be the CR equation? Ux is equal to vy. Whether the ux is equal to vy or not? Yes, here ux it's equal to vy. Yes or no? 2x minus 2y. Yes, it's equal. Both are equal. Second one, second thing, it's uy must be equal to minus of vx. Yes, and if you take the uy and if you multiply this value by minus, yeah, it's equal to, it's satisfied, right? Uy is equal to minus of vx, and if you multiply the vx by minus, then it's equal to uy. Now the CR equation is satisfied. Cauchy-Riemann equation is satisfied. Therefore the given function w is an analytical function of z. It's an analytical function of z. Is it clear now? Okay, now we are going to discuss the previous year questions. It's one example for the complex variables analytical function. First question. Now phi of x comma y and psi of x comma y are the functions with continuous second derivatives. Then it can be expressed it's equal to x plus, yes, I psi, x plus I psi. And what will be the formula? I will explain with x first. Z is equal to x plus Iy means, x plus Iy means, so what we are doing here, v plus u plus v we are taking, right? Yes, it's equal to u plus iv. If it is u plus iv means, now I am going to substitute, it's dou u divided by dou x, it's equal to dou v divided by dou y. It's first formula. Second one, dou u divided by dou y, it's equal to minus of dou v divided by, it's dou x, right? So what they are giving here, instead of x, it's pi and psi. Okay, it's pi and psi, not it's x, it's pi, right? It's a pi, it's pi and psi they are giving, pi and psi they are giving, right? Instead of u, it's psi, it's v, right? Now substitute u and v, and we can get, now it's u is replaced by its psi divided by dou x, v is replaced by, it's a psi, right, divided by dou y. Now dou psi divided by dou y, dou psi minus dou psi divided by dou x. Where the formula is available, look at this condition, dou psi divided by dou y. Yes, it's option B, right? Look at this condition. Now dou psi divided by dou y is equal to minus of dou pi divided by dou y is equal to dou psi divided by dou x. It's psi pi, it's a pi, second one psi, so dou pi divided by dou y is equal to minus of dou psi divided by dou x. The option B satisfies the condition, right? Okay, the next previous question. Now the analytical function of a complex variable z is equal to x plus iy is expressed as f of z is equal to u of x comma y, u of x comma y plus I into v of x comma y, where I is equal to root of minus 1. If u is equal to xy, the expression for v should be, what will be the expression for v? What will be the expression for v? So this is what we need to identify. Now the formula, first I will write the formula. It's a simple thing we can write. Instead of writing the whole value, it's ux. Ux means it's dou u divided by dou x. Ux is equal to, it's vy. Second condition, uy. Sorry, it's not v, u. Uy, it's equal to minus vx. Is it clear? It's a formula. Now z is equal to x plus iy. They are giving in terms of v of x comma y, v of y. Now the u they are giving, what will be the u? U is equal to xy. What will be the value for v? V value we need to identify. There are two methods are there. First method I will explain it. Next one followed by u is equal to xy, and ux is equal to y. The same, it's equal to vy. So now from this equation check it. What value we are getting? What value we are getting? First one, ux is equal to y. Therefore it's equal to vy, right? Now if you differentiate the v with respect to y, we will get y. We will get y. Now differentiate it with respect to y. We won't get, right? It's not possible. So 2 into x plus y into 1 divided by 2. X plus y we are getting, it's not possible. So while differentiating, so these are all the v functions, the given function among the a, b, c, d. One of the option is the v. While differentiating the v with respect to y, it's equal to x as per the Cauchy-Riemann equation. Whenever the function given function satisfies the CR equation, it is called as analytical function. Or if the function is mentioned as analytical function, then it must satisfy the CR equation. An analytical function of complex variable they are giving. So the given function itself it is an analytical function, so it must satisfy the CR equation. We know the CR equation, ux is equal to vy, ux is equal to vy, right? Okay, now u value they are giving, u is equal to xy. If you differentiate the u with respect to x, y, it's equal to vy as per the CR equation. So if you differentiate the v with respect to x, right, then it's equal to, it's not possible. And if you differentiate this function with respect to y, then what we will get? 0 minus 2y divided by 2. We are getting minus y. Then this option also not possible. Here also it's not possible. So only option, it's 2y minus 0 divided by 2, it's equal to y, while differentiating with respect to y. So the option C is the right answer for this question. Is it clear? Guys, in case you are having any doubt, so immediately ping your doubt in the live chat box YouTube, then I will give you the clarification for your doubt. Next one. Now again, this question also, it's analytical function related question. An analytical function of a complex variable z is equal to x plus iy. So the given question itself, they have mentioned it as analytical function. So the given function is analytical one. F of z is equal to u of x comma y plus I into v of x comma y, where I is equal to root of minus 1 if u of x comma y is equal to 2xy. U of x comma y is equal to, it's 2xy. Then v of x comma y, what about the value of v of x comma y? Now the same formula, I will explain it. Look at, it's a mechanical engineering GATE 2014 set to question. Now the function is analytical function. Given function is analytic. Therefore, it must satisfy the CR equation. The CR equation is called as Cauchy-Riemann equation. It must satisfy the CR equation. And what about the CR equation? It's ux is equal to vy. And what will be the value of u? Here they are giving u is equal to here, and if you take the value, u is equal to 2xy, and if you differentiate the ux is equal to vy is equal to, it's 2y, right? And if you differentiate the given u with respect to x, it's equal to 2y, and the options are the v. So any one of the option, it's equal to v, right? So now if you differentiate the given options with respect to y, we need to get, it's 2y, right? So and in the two options we are getting, and if you differentiate the function with respect to y, in the two options we are getting 2y, right? In option A we will get 2y, in option C also we will get 2y, in option B and D it's minus 2y, it's not the part. In the two options we are getting, so here itself we can eliminate, we are not getting plus 2y, so minus 2y we are getting, so we can eliminate. But coming to this condition, we are getting plus 2y in the two options, option A and C. So we need to do the we need to cross verify the one more equation. What will be the second equation for the CR equation? It's ux is equal to vy, one more equation, uy is equal to minus vx, uy is equal to minus vx, it's minus into vx differentiation, it's equal to, what about the uy differentiation? So we need to take the value, okay, yes, it's vx, right? And what will be the uy? Uy with respect to differentiate the u with respect to y, it's equal to 2x, it's equal to 2x, it's equal to minus into minus 2x, minus into minus 2. If you get the 2x only, then we will get it's equal to, then it's a Vx, right? Vx must be minus 2x. Vx must be minus 2x. And where we are getting the minus 2x? Here we are getting plus, so it's not the option, right? Here we are getting it's minus 2x. While differentiating with respect to x, we are getting minus 2x. Therefore, your option C is the right answer for this question. Next one. The one more question, the same equation. Look at this two question. It's 2014 set to mechanical engineering question. The same question were repeated in the 2016 also, after 2 years. The same u of x comma y is equal to 2xy. What will be the value of v? And the same, it's option A, minus x square plus y square plus constant. And if you differentiate the constant with respect to y, or it may be and with respect to x, it's 0. Next one. Now again the analytical function they are giving. A function f of complex variable that is equal to x plus iy is given as f of x comma y, which is equal to u of x comma y plus I into v of x comma y, where u of x comma y is equal to 2k xy. V of x comma y is equal to x square minus y square. And what will be the value of k? So they are giving the function. The function itself they have mentioned it as, the given function is analytical one. Here f of x comma y is equal to u of x comma y plus I into v of x comma y. I into v of x comma y is an analytical function. Is an analytical function. Whenever the given function is analytical function, then it must satisfy. Therefore, it satisfies. It satisfies CR equation. And here polar equation. Here polar equation or Cartesian. It's Cartesian equation. It satisfies ux is equal to vy and uy is equal to minus vx, and the u and v they are giving in the question itself. The value of k we need to identify. And coming to the u is equal to 2k xy, v is equal to x square minus y square. Now the substitute ux is equal to vy, u with respect to x differentiation 2ky, then it's equal to v with respect to y differentiation minus 2y. And what about the value of k is equal to minus 1? Here k is equal to minus 1. If you cancel the LHS s plus RHS 2y, the value of k is equal to, it's minus 1. Is it clear now? Minus 1 is the right answer for this question. Next one. If f of z is equal to x square plus a into y square, x square plus a into y square plus ibxy is a complex analytical function. So the given function is that f of z is analytical function. Analytic function. Therefore, it satisfies the CR equation. Therefore, it satisfies. It satisfies the CR equation. Is it okay now? And what will be the CR equation? Now, it's ux is equal to vy and uy is equal to minus vx. Now, what about the value of u? Here it's u. So, it's u. Here it's v. Now, u is equal to x square plus a into y square. V is equal to vxy. Now u is equal to vy as per the first equation. Ux is equal to vy. Now 2x it's equal to, what about the value? With respect to x it's 2. With respect to y it's vx. Therefore v is equal to 2. v is equal to 2. It's first one. Second one, uy is equal to minus vx. Uy 2ay, vx minus into with respect to x, it's by. Now the b value, now substitute, it's 2ay, it's equal to minus 2y. Now cancel it. A is equal to, what about the value? A is equal to, it's minus 1. Is it okay now? And A is equal to minus 1, B is equal to 2 is the right solution. A is equal to minus 1, B is equal to 2. It's option B. Next question on the complex function. F of z is a complex function, complex variable. Z is equal to x plus iy is given by. Now f of z is equal to iz plus k into real part of z. What is the real part of z here? It's a real part of z we need to take. Real part of z is equal to x. Now the imaginary part of z is equal to, it's equal to y, right? Now substitute f of z. So first we need to take the value of f of z. So coming to the f of z is equal to I into x plus iy. Z is equal to x plus iy, right? Plus k into real part of z is equal to x plus I into y. Now multiply the I inside. It's ix plus I square y plus kx plus I into y. Now the I square is equal to, I is equal to root of minus 1. I square is equal to minus 1 as per the complex variable function. It's equal to I into x minus y plus kx plus I into y. Now split the imaginary part as well as real part. Kx minus y plus I into x plus y. Now take the u and v. U is equal to kx minus y. Kx minus y. V is equal to x plus y, right? Now the CR equation. As per the CR equation, ux is equal to vy. Now ux, ky, with respect to vy, it's equal to 1. Is it clear now? Yes or no? Ux is k minus, sorry, it's k minus y, right? Excuse me. Yes, it's k with respect to x, k minus y. Oh, sorry, it's imaginary part is equal to I into y. So we need to substitute the I into y here. Then you will get directly. Okay, fine. So coming to this equation, u is equal to, ux is equal to, it's k minus y. It's vy is equal to 1. Vy is equal to 1. So this is what we are getting, right? And if you compare the value with the another equation, then, oh sorry, it's I into y, right? Imaginary part is equal to I into y. Ix plus minus y plus k into real part of z. Here it's I into y. So it's I square, here we are getting I square, we are getting, right? And if you take the I square, excuse me, okay, fine. It varies here completely. Wait a minute, I will explain. Okay, it's equal to, now multiply the I inside, and if you multiply the I inside, it's Ix minus y and plus kx, it's minus y, and if you take the I and y, it's kx minus 2y, right? Imaginary part we are getting, so we need to take its minus, it's equal to, it's 2y. plus I into x. Is it clear now? Is it clear or not? Okay, fine. And if you differentiate the CR equation, and we are getting its u is equal to kx minus 2y, and v is equal to its x. V is equal to x. Now we need to differentiate it with respect to x and y. And if you differentiate it